If Q is slightly displaced, then it performs SHM. It is displaced along x-axis from its mean position. We have to show that it performs SHM, as well as we have to calculate time period. So actual distance Q1 and Q2 separated by L distance, that is the distance between Q1 and Q2 is L. If a third charge placed at midpoint, at that point F net is equal to 0, right? So distance from Q1 to Q at midpoint, at mean position nothing but at midpoint. At midpoint, F net equal to 0 for external charge. Already we proved that. Therefore, distance from Q1 to Q is L2. And here also distance from capital Q2, that small q2 is also L2. Okay. Actually, both are equal charges. So just I have given 1 and 2 numbers. Right. Now, force on capital Q with respect to small q. Force on capital Q with respect to small q should be this direction. Okay, now force on capital Q with respect to small q should be in this direction. Right? Both are positive. Repel. Let this is take this as F1. Now write F1 immediately. What is F1 force? F1 is equal to force on capital Q with respect to small q1. Okay, with respect to this charge, that is F1. Should be right side, force direction. Just apply Coulomb's law. F1 is equal to KQ capital Q by distance between the Q and this Q. Okay, this red Q is at mean position. We have displaced it slightly in x direction. Okay, we have taken that slight distance is small x. Now charge on this block Q, that is displaced charge. Got it? Now distance from this Q to this displaced charge L2 and this x distance totally, that is L2 plus L by 2 plus x whole square. Got it? Distance from this Q and capital Q is L by 2 and x, that is L by 2 plus x distance. So according to Coulomb, we got F1. Now write second force F2. F2 should be, what is F2? Force on capital Q due to this Q2. It should be in this direction, right? This is F2. F2 is equal to, again you can write K into Q capital Q by, now distance. Original distance is Q and Q2 distance is L by 2. Now Q displaced towards Q2 x distance. Therefore, this L by 2 distance change to L by 2 minus x. According to Coulomb law, denominator is distance square. Got it? Now apply F net. Take F net here. F net is equal to F1 plus F2. F1 KQ by L by 2 plus x whole square minus KQ by L by 2 minus x whole square. Right? F1 is this direction, F2 is this direction. That's why I'm taking minus simply. Right side, vector right side positive, vector left side negative. Simple logic. Now solve this. Now simple mathematical simplification. What you have to do now? Take KQQ common. Take KQQ common. Then here it is 1 by L2 plus X whole square minus 1 by L by 2 minus X whole square. Now from here completely mathematical simplification. We have taken KQQ common. Now take LCM and solve it completely. From here it is very easy at simplification. Just a plus b whole square and a minus b whole square expansions. Very important method. Application of Shm in electrostatic. Now you can write KQQ of that LCM is product of these two. You can observe here product of these two is this is a plus b and this is a minus b, a square minus b square. Directly I am writing L by 2 whole square minus b square. Why? Because this is a plus b, this is a minus b. A square minus b square and whole square is there. Just write that as it is. Now the numerator is cross multiplication L by 2 minus x whole square minus L by 2 plus x whole square. All you know the numerator is nothing but a minus b whole square of a minus b whole square minus a plus b whole square. Got it? Right. What is a minus b whole square and a plus b whole square? A minus b whole square minus a plus b whole square is nothing but minus 4ab. Right? A minus b whole square minus a plus b whole square is equal to minus 4ab. Then what is the numerator there? Minus 4. Right? Then f net is equal to, this is completely f net is equal to KQQ into a minus 4ab minus 4. What is a? A is L by 2. What is b? X. Right? A minus b whole square minus a plus b whole square minus 4ab by, what about this? Here we have displaced that capital Q to x distance. Comparatively, this x is very smaller than L. Therefore, what is the concept here? Higher powers of x should be neglected. Okay, so this x length is very small compared to the top original length. Therefore, higher power should be neglected. Higher powers means more than one x power should be neglected. So here x square whole square is there, x to the power 4. In this expansion, you get x square term and x power 4 term. Just you neglect those. That means no need to write. Okay. Now you just write only L by 2 terms, L by 2 whole square and one more whole square is there. Therefore, directly this is L by 2 whole to the power 4. Got it? This is actually F net value. Now simplify this. Why we have neglected that x power 4? I have given reason, right? Okay. Now come to the next part. So this F net can be written as, now this F net is equal to KQQ into, that is 4 by 2 is 2 minus 2LX by L power 4 by 2 power 4 is 16. Now this 16 moves up, therefore you get F net as, F net is equal to minus 32 KQQL by L to the power 4 into X. Okay, I have written X separately. Now this F net you can write it as minus 32 KQ capital Q by L cube into X. Okay, now what is F net SHM concept? That SHM concept is F net should be equal to minus Kx. That is standard equation for SHM. So after calculating this F net, we got F net is equal to minus 32 KQQ by L cube into X. Okay. Now clearly this is in the form of F net is equal to, here in the bracket all are constant terms, simply you can write minus Kx. Okay, the charge, external charge capital Q displaced from its mean position. After displacing, the F net is minus Kx form, therefore it performs SHM. Right? Then here you have to calculate time period. Okay, now we have to calculate time period. Observe how to calculate time period, right? Okay, so once again I am writing here to calculate time period. What we got F net, that F net is equal to, we got it as minus 32 KQ capital Q by L cube into X, right? This is our F net value. Now all you know that F can be written as M into A. Now write MA is equal to minus 32 KQ capital Q by L cube into X. Therefore, what is the acceleration from here? A is equal to minus 32 KQ capital Q by ML cube into X. This is acceleration. Got it? Now, what is acceleration in SHM? Okay, so in SHM, that acceleration A is equal to minus omega square x, right? So in SHM, what is A? Minus omega square x. Here A is equal to this much. Compare these two. Now you can write minus omega square is equal to minus 32 KQ capital Q by ML cube. Got it? Minus minus gets cancelled. You get omega. Omega can be written as under root 32 KQ by. So all these are simple mathematical steps along with physics formula. Okay, right. So we got omega. Now finally, what is the time period? Time period, you know that T is equal to 2 pi by omega. Right? What is time period? T is equal to 2 pi by omega. Now here T is equal to 2 pi by omega. This is under root, write omega as it is 32 kq capital Q by ml cube. Or you can write another way, T is equal to 2 pi into, this whole thing is 2 pi by, write 2 pi into reciprocal of this numerator by denominator, you get ml cube by 32 k q and capital Q. Okay, this is time period formula. Very important method, how to calculate time period if charge perform SHM. Okay, in electrostatic concept, very useful.